Hello students, today we are understanding about the exponent and powers. So let us begin. What is the meaning of exponent and powers? So an expression that represents repeated multiplication of the same factor is called a power. Like this, in this example, as we observe 10 and on the topmost right corner of 10 it is written 9, and this meaning is 10 multiply 9 times. So this 9 is the exponent which shows the repeated multiplication of 10 9 times. This 10 is called the base, and this full 10 raised to the power 9 is known as the power. Now here we have to pronounce it as 10 to the power 9 or 10 raised to the power 9. So here a power is represented with a base number and an exponent. The exponent, a small number written above, tell how many times the base number is being multiplied. So here 10 raised to the power 9 shows that 10 multiply 9 times. This exponent is also known as power or indices. Here is some laws of exponent. In place of x, we can use any variable a, b, c up to z. So, laws says x raised to the power 1 is x. X raised to the power 0 is 1. X raised to the power minus 1 is 1 upon x. X raised to the power m into x raised to the power n is x raised to the power m plus n. X raised to the power m upon x raised to the power n is equals to x raised to the power m minus n. X raised to the power m whole raised to the power n is equals to x raised to the power m into n. Xy whole raised to the power n is x raised to the power n into y raised to the power n. X upon y whole raised to the power n is equals to x raised to the power n upon y raised to the power n. X raised to the power minus n is equals to 1 upon x raised to the power n. Beside of this, we have one more law of exponent which is known as fractional exponent. A fractional exponent is an alternate notation for expressing powers and roots together. This fractional exponent also called radicals or rational exponent. This law says a raised to the power 1 upon n is equals to nth root of a raised to the power m upon n. Now here we are talking about the rational exponents. In this laws of exponent, what we have learned that the n is not a rational number. It is an integer. Whereas in this rational powers, we are talking about the exponents are in the rational numbers. So here a raised to the power m upon n is equals to nth root of a whole raised to the power m, or we can say nth root of a raised to the power m. On the basis of these laws, let us solve some problems. Exercise 12.1. Question number 1 says, evaluate minus 4 raised to the power minus 2. Now as by the laws of exponent, we know that a raised to the power minus m is a raised 1 upon a raised to the power m. So this minus 4 raised to the power minus 2 becomes 1 upon minus 4 square. Now minus 4 square meaning is minus 4 multiply 2 times So 4 into 4 is 16. Minus 4 and minus 4 multiplied gives 16. So here we can say minus 4 raised to the power minus 2 is 1 upon 16. Let us talk about one more variety of problem. We have to simplify and express the result in power notation with a positive exponent. So here the problem is given minus 4 raised to the power 5 divided by minus 4 raised to the power 8. So here we can say, as by the laws of exponent, we have a raised to the power m divided by a raised to the power n is equals to a raised to the power m minus n. Exponents will be subtracted. So here minus 4 raised to the power 5 divided by minus 4 raised to the power 8 becomes minus 4 raised to the power 5 minus 8. Now 5 minus 8, we know that minus 3, so it will become minus 4 raised to the power minus 3. Now again, as a raised to the power m, this becomes 1 upon a raised to the power m. So in the positive power notation, we can write it minus 4 raised to the power minus 3 as 1 upon minus 4 raised to the power 3. As we have to write the result or write the answer in power notation, so this is sufficient, where this 3 shows the power of this minus 4 and also with the positive exponents. So in this minus 3 we have converted as power positive 3. So we can say now the answer for minus 4 is to the power 5 divided by minus 4 is to the power 8 is equals to 1 upon minus 4 is to the power 3. Now same problem, one more variety, 3 raised to the power minus 7 divided by 3 raised to the power minus 10, and this result multiplied by 3 raised to the power minus 5. As we know that when we solve the mathematical operations, so first of all we have to solve the quantities which are inside the bracket. So here we solve this 3 raised to the power minus 7 divided by 3 raised to the power minus 10 first. So by using the law, a raised to the power m divided by a raised to the power n is equals to a raised to the power m minus n. When the base are same and exponents are different and they divide, then we get the exponents will be subtracted. So 3 raised to the power minus 7 divided by 3 raised to the power minus 10 becomes 3 raised to the power minus of minus 10. So it will 3 raised to the power minus 7. This minus and this minus becomes plus. So minus 7 plus 10. So here we get 3 raised to the power 3. Now after this bracket quantity we solved, this should be multiplied with 3 raised to the power minus 5. So in the next step, this 3 raised to the power 3 multiplied by 3 raised to the power minus 5. Now again here, by the law of multiplication, we have a raised to the power m multiply a raised to the power n is equals to a raised to the power m plus n. So here in the product, exponents have to add. So it will become 3 raised to the power 3 plus minus 5. So we get 3 raised to the power 3 minus 5 is 3 raised to the power minus 2. Now here this exponent is negative, so we can write it as the positive notation by using a raised to the power minus m is 1 upon a raised to the power m. So we get 3 raised to the power minus 7 divided by 3 raised to the power minus 10 multiplied by 3 raised to the power minus 5 is 1 upon 3 square.